The next problem that we will discuss deals with vertical rectilinear motion, or motion that is directly influenced by gravity. But before we proceed with the next problem, let us first introduce the notations or the sign conventions that we need to remember in analyzing vertical rectilinear motion. The displacement s is positive if the position of the object is above its initial position, while it is negative if the particle is below its initial position at a certain point in time. On the other hand, the velocity v is positive if the particle is moving upward at a certain point in time, while it is negative if the object is in a downward motion. This is the second problem under motion analysis. Please take some time to read and understand the problem. We can visualize the trajectory of the stone using this simple diagram. Its initial point is at point 0. The maximum height that it can attain is at point 1, and its final position once it falls back to the ground is at point 2. For us to solve this problem, we must first determine the differential equation that we must solve. Since the stone moves vertically, then its motion is directly influenced by gravity. Therefore, the differential equation in this problem is the second derivative of s with respect to time equals negative 32 feet per second squared. Remember that the value negative 32 feet per second squared is the standard acceleration due to gravity in English units. Since we have a second order differential equation, then we must find two boundary conditions. Now, since we are given the initial velocity of the stone, then we can express the first boundary condition in this way. When t is equal to the time 0 second, v is equal to 128 feet per second. For the second boundary condition, we must analyze the problem very carefully. Besides the velocity of the stone as it is being thrown upward, or besides the initial velocity of the stone, what else do we know about what happens at the initial time t is equal to 0? We know that the stone has not left the hand of the one throwing it. So we can express the second boundary condition in this way. When t is equal to the initial time 0, the displacement s of the stone is still 0 foot. From this given information, we must find the time it takes for the stone to reach the ground, denoted as t sub 2, and the velocity by which it hits the ground, denoted as v sub 2. For us to solve these two quantities, we must first express the velocity v as a function of time. We first write our differential equation in this way. Then we cross-multiply to the right side of the equation dt. After this, we now integrate the left side of the equation with respect to velocity, while the right side is integrated with respect to time. After integration, we will arrive at this form of the equation for velocity. Notice that when we apply the first boundary condition, we will be able to find the value of c sub 1 and determine the function of time corresponding to the instantaneous velocity of the stone. Now, before we proceed, notice that the formula for velocity that we have just derived is just the same as one of the three equations of motion that you have been using in physics. Now, the second function of time that we must determine is that which corresponds to the displacement s. We now write the equation for velocity that we obtained in the previous slide in this manner. Then we cross-multiply dt to the right side of the equation and integrate both sides of the resulting equation. This is the resulting formula for the displacement s. If we apply the second boundary condition, then we can compute for the value of the second arbitrary constant c sub 2 and determine the function of time corresponding to the displacement s. Again, before we proceed, isn't it that the equation for s that we have just obtained is the same as one of the basic equations of motion that we have been using in physics? Now, we shall solve for the time it takes for the stone to reach the ground. For us to solve this, or for us to solve t sub 2, we must be aware that at point 2, the displacement of the stone is already 0. Using this information and the formula for the displacement s, we can now find the values of the time at which the displacement is 0. Notice that we were able to find two values of time. But remember that 0 second is our initial time, or the time at point 0. So the answer that we are looking for is 8 seconds, which is the amount of time that it will take for the stone to reach point 2. Now for us to solve for the velocity of the stone as it strikes the ground, we use the formula for the velocity that we have obtained in the previous slide. We now substitute the value of t sub 2 for time in the formula, and we'll finally be able to get negative 128 feet per second as the velocity of the rock at point 2. Now it is just natural for us to get negative as our answer since we know that at point 2, the stone is moving downwards.